Yes, it is the class on haloalkane and haloarenes, and today I will specifically mention on physical properties and reaction mechanism on this chapter, and it is set number 3, and it is the solutions of NEET, JEE, IIT, PIMT, AME, Medical, VAT, EE, APSET, UPSCAT, AIEEE, and PAT and CAT, etc. A lot of things. Questions answer has been solved, and along with some probable important questions has also been solved along with this. So please follow my physics in chemistry and not new classes I myself has done. Please follow the class in YouTube. So list boiling point. So the trick, I will follow the trick. What is the trick? Boiling point is proportional to surface area and proportional to molar mass or weight. Means if the surface area of a substance is less, means more branching, if there is more branching, less is the surface area, less is the boiling point. Am I right? And if the molecular weight is mass, upon these 2 points, the boiling point depends. So you plus, please go through the questions and you will find which one has the least boiling point. The answer is you directly go to the question point number 4, tertiary butyl, and go to the trick. Less the surface area, less is the boiling point. That is more the branching, less is the surface area, less is the boiling point. So out of these options, you don't read all the options, you just go to the tertiary butyl chloride. Tertiary butyl chloride is, this is tertiary butyl chloride, and out of 3 options it is branched and surface area is less, hence its boiling point is less. Question number 2. 1-iodobutane has more boiling point because it is directly proportional to the molar mass. Only resonance structure is possible, and due to its resonance stability, it will not be easily hydrolyzed. So it is least reactive. Other option does not have the resonance stability. Hence, answer least reactive substance is vinyl chloride. Here, you are asked to arrange in terms of reactivity, and you please go through the stability. Here, it is highly stabilized due to the resonance of this lone pair along with the benzene ring. Am I right? And here it is vinyl chloride. A bit earlier I have shown that you will also get some stability, but structure is less. It has got more structure, so it is more stable. This is second stable, and third it is least stable. So least stable is more reactive. So A is the least, then B, then C. You just see the stability. More stable get more resonating structure. Only 2 resonating structure. Comparison to this, it is less stable, and it is further less. Less the stability, more is the reactivity. The question is, alkyl halide is less soluble in water. There are lots of options you are given, and which option is correct? The option I have chosen here is has no ability to form hydrogen bond with water, that is intermolecular hydrogen bonding is not possible with alkyl halide, hence it is less soluble. It is the option along with other and is the correct option. Of electron with the benzene ring, and here if it is removed, then if it becomes cation, then this bond is withdrawn. In this way you will get resonance. So the stability of that part is more than that, am I right? Hence it is more reactive. Benzyl chloride is more reactive. The question, which one of the above compound will show SN2 mechanism with complete inversion? Answer, 1 degree alkyl halide show SN2 mechanism with inversion, and 3 degree alkyl halide show SN1 mechanism with racemization. I will explain it a bit later on this part, extra information. So 1 degree alkyl halide show SN2 mechanism with inversion, means there is a transition state. That is, your answer C is correct, because here methyl chloride, when you react with a nucleophile, then nucleophile attacks in this way, nucleophile attacks in this way, and here what's happened, this tries to go out, and here nucleophile makes a transition state, and that transition state finally give you the answer. This means the HH bond was in the left, and finally you that got HHH exactly inverse, reverse of this one, and since it proceed to transition state, means one single step reaction, it is SN2 mechanism. So SN2 mechanism is only seen in case of 1 degree alkyl halide where inversion occurs. So option C is correct. Product. So one of the important things here is that when potassium hydroxide is aqueous, substitution reaction occurs, and when potassium hydroxide is alcoholic, elimination reaction occurs. Am I right? And whenever there is a question of elimination reaction, then Sidjeff rule comes. Sidjeff rule. So what is Sidjeff rule? Sidjeff rule, a lots of definition is given in the book, but I will show you a trick, just to follow this one. So this group, with respect of this group, towards the right is beta, and towards the left carbon is also beta. Say this is beta 1, this is beta 2. You are getting 2 beta carbon. One is with respect of this Br, bromine, because there is dehydrohalogenation. Hydrogen and halogen will remove to get elimination, and it will be dictated by Sidjeff rule to get the major product. So how will you get the major product? So out of these 2 beta, it is 1 beta, this is 2 beta. The beta which has less number of hydrogen will be eliminated from that beta, and that answer or product will be your major product. So blindly you do one thing, you remove 1 hydrogen from here, that make it that 1 hydrogen from here, so that will be removed, bond will be inclined, and this will go away. So what we get here is CH3 CH double bond CH CH3. This is major product. So the point is, B1 on both sides, B1 and B2, the carbon which contains less number hydrogen from that carbon will be eliminated. So you just remove 1 hydrogen from here and make double bond here. This will be your major product. You don't think anything more. Alcoholic. Again your answer is elimination product and Sidjeff rule. 1 chlorobutane means, what does it mean? 1 chloro, am I right? So 1 chlorobutane, here no option is here, this is alpha, this is beta, no beta from left, only 1 beta is there. So your option is just you remove one hydrogen from here, make bond here and remove here. So what we get here is CH2 double bond CH, CH2 CH3 is your final product. Chloride, this is start butyl chloride and it is 3 degree alkyl halide. A bit earlier I have told you, if it is 3 degree alkyl halide, then it will very easily undergo SN1 mechanism. If it is 1 degree or 2 degree, it will go SN2 mechanism, though there is some exception if there is an equation of rearrangement. That matter is another thing I will explain in course of time. So you check which one is 3 degree alkyl halide. So we have seen butyl chloride or tart butyl chloride is nothing but a 3 degree alkyl halide and it will undergo SN1 mechanism easily or efficiently. Alcohol. Again it will be explained by Kashrul, 2-bromopentene. This is 2-bromopentene. So now again the question comes, the trick, what trick you will do? Kashrul, nothing to memorize, nothing to learn, just you see, this is beta 1, this is beta 1, beta 2. What I told, the beta carbon which has less number of hydrogen will be eliminated from that carbon only. So you need not try any option, just you remove that hydrogen, arrange the double bond here and remove it. So your answer is CH3 single bond CH double bond CH bond CH2 CH3. This is your major product. Your question was 2-bromopentene when reacted with potassium hydroxide alcoholic, what will be the major product? Answer, your major product is this. So first of all, here you see CH3 CH2 Br. When it is treated with lithium aluminum hydride, you will get a hydride. So hydride will here for the first case, the hydride, it will give hydride will attack here, am I right? Thereby it will go. So it is a type of nucleophile. So what's happened here? One is attacking, other is going, is a single step reaction. So your mechanism is SN2 for the first reaction. Now for the second, am I right? Again lithium aluminum hydride, but here you see it gives hydrogen. Now what's happened? From these two, here hydride will take this electron out. So what you get here is CH2 CH3 CH3 plus hydrogen, am I right? Hydrogen. So here what's happened, in a single step reactions you are getting elimination reaction. So single step elimination is E2. So if this is SN2 and this is E2 mechanism. What is the answer? Very simple. Phenol, you got the reaction, OH, the reaction, sodium will enter, you will get this. When on hydrolysis with this, then this will be replaced by H. Answer is phenol. Nothing to explain, it is known to you. Reaction, benzyl chloride, sodium hydroxide aqueous. A bit earlier I have told you, when sodium hydroxide aqueous is there, then substitution occurs, am I right? And when sodium hydroxide is or potassium hydroxide is alcoholic, elimination occurs. So since it is aqueous, then sodium OH will be replaced here. So you will get CH2OH, and when it is treated with HNO3, so it is oxidizing agent. So you know CH2, the trick is CH2 group on oxidation becomes CHO. So your answer is benzaldehyde. So A is this, B is this. Simple trick, on oxidation CH2 becomes CHO, because dilute nitric acid is a mild oxidizing agent. So it might be transformed into COOH, but due to its mild nature, it will be stop at CHO. Everybody of you know this is Dawes reaction. Keep it in your mind. This is Dawes reaction. And the answer, again, it is very simple question. KCl, C6Cl, KCl, only this part is replaced by Cl. So you write C6H5Cl, and on acid hydrolysis, that Cn groups transform into COOH. So propanoic acid. So the trick is that cyanide group on acid hydrolysis transforms into COOH groups, and it is known to you that Cn will come to here. This is Cn, and that Cn group on hydrolysis, acid hydrolysis, Cn groups will convert to COOH. You please keep this in your mind. Simple, nothing tough. And you are asked which one of the following will not be the product. So let us first find which one will be the product. If you can find out which one will be the product, then which one will not be the product will easily be found out. So let us see. When there is, the trick is sodium and ether. When in a reaction of alkyl halide, sodium and ether is there, it is nothing but Wurtz reaction. But there are some other types of reaction may be present. Wurtz fitting. Wurtz is alkyl halide, but if there is any aromatic halide, aryl halide, then there may be some other name reaction. Let us see. So the first thing is that when methyl bromide is there, so according to Wurtz reaction, that will come twice. Am I right? And sodium twice. This is Wurtz reaction. Probably you have got in first year. So the trick is that sodium and bromine will give you sodium bromide, and in dry ether it will give you CH3, CH3. One answer is over. Other, you are getting aryl halide. This is aryl. So along with this, you add twice sodium and made aryl halide twice. Dry ether same. Again, it is worst type of reaction. Hence, the trick is that you just remove all this, and you will get diphenyl. Am I right? You are getting diphenyl. So two options you have got. Another option left out is that alkyl halide and aryl halide may combine all together. So you are getting, this is aryl halide, twice sodium as earlier, and this is alkyl halide. So these two will come out in presence of dry ether, and what you will get is toluene. So the probable answer is alkene, diphenyl and toluene. What answer is not there in the option will be your answer, or product will not be given by this reactant when react with sodium in dry ether. And one thing, this is Wurtz reaction, this is fitting reaction, and it is fitting and Wurtz combined, so Wurtz fitting reaction. If Neum reaction is asked in the entrance exam also, you can write this. Gives, there is two conditions using NH2, so your answer will be CH3 NH2, again CH3 NHCH3, again CH3 and CH3 again CH3 CH3. So you are getting 1 degree, 2 degree, 3 degree, and 1 salt plus, am I right? Plus salt, tertiary salt. So the condition is that if alkyl halide is excess, if alkyl halide is excess, you will get 1 degree, 2 degree, 3 degree, and salt. The reaction is very simple, that first we have got amine has entered, and second one hydrogen is replaced, another methyl group has entered, another hydrogen is replaced, another methyl group entered, another is replaced, another methyl group entered, means in each and everywhere you are getting alkyl halide, means alkyl halide in excess. When you will get 1 degree, 2 degree, 3 degree, and salt. But if ammonia is excess, if this is excess, only 1 degree will be your measure. The point, you please keep it in your mind. If alkyl halide is excess, in every step you will add up alkyl halide, and you go on decreasing the number of hydrogen, and finally you will get a salt, means 1 degree, 2 degree, 3 degree, everything you will get. But if ammonia is excess, you will get the major product at 1 degree alkyl halide. Be here, the question very often asked in different type of exam, entrance exam. Means the carbon should contain 3 different element or group of elements. Then that carbon is called chiral, that molecule is chiral. This is the condition. Just out of all this option, you please see 2 bromobutane. So CH3, CH2, Br, CH2, CH3. This compound is 2 bromobutane. So now you arrange. You will find when you talk about this carbon, so along with this carbon, 1 bromine is there. Above this you can write 1 hydrogen, and towards left 1 methyl, and towards right 1 ethyl. So that carbon is surrounded by 4 different groups of atom. Am I right? So that carbon is chiral carbon. That is 2 bromobutane will show chirality. And you draw the structures of other, you will find somewhere there is some similarity in that carbon. In that carbon you will get more hydrogen, 2 hydrogen same, or 2 methyl groups same. In this way some similarity you will get A, B, C, D. Somewhere there are some same things will be attached. If this thing happens, the molecule is not chiral one. Only this molecule is chiral, where carbon has 4 different things or elements or group of atoms attached, is called chiral. You are asked which one of these molecule will show when it will be attacked by nucleophile. So in nucleophilic substitution reaction, a racemic mixture will be shown by which of the following product? At the very beginning, I told you 3 degree alkyl halide show you SN1 mechanism. means carbocation will form. And number 2, racemic mixtures appears if the alkyl halide, which is supposed to be 3 degree, if the carbon contains 4 different hands, 4 different substituents are attached with the carbon, then this alkyl halide, 3 degree alkyl halide, which follows SN1 mechanism, will give you racemic mixture. Now, what is racemic mixture? Racemic mixture means, say, let us take this one. This is methyl group, this is ethyl group, this is bromine, and this is hydrogen. Am I right? So, here it may not be in terms of degree, 3 degree alkyl halide, but that carbon is chiral. But in case of here, if you go to this one, if you see these two are same, so the lack of chirality. So the chiral atom where alkyl halide with chirality will show SN1 mechanism, means bromine will be replaced. In place, one nucleophile will enter like OH. If it is potassium hydroxide aqueous, answer will be, say if it is react with potassium hydroxide aqueous, you will get this answer. But here, whenever you have this, these 4 are different. So your product is either OH is towards right or towards left. There is 2 possibility. Say you can write in this way also. Since the structure of this, or OH is above, OH is below, because here p orbital is there, p is a dumbbell in shape, p is in dumbbell in shape. So either OH is in this vacant place or OH is in this vacant place, or OH is dumbbell is y-axis above or OH is below. Structurally, these 2 product is different in terms of optical activity. Means if this compound in the solution rotate the plane polarized light when passed through it, if it rotates towards right at certain angle, so the solution of this, upon which if the same polarized light is passed, it will rotate the plane polarized light to the same extent to the left as it done in the earlier. So if it rotates at 60 degree towards right, so this will rotate at 60 degree towards left. That is, finally, the combination of this product will give you optically inactive. No rotation at all is there. Rotation towards right is compensated to the rotation towards left at the same extent, same degree. It gives you a inactive solution of 2 products, and that combination is called racemic mixture, and that process is called racemization. So final condition is that if it is CH3, if it is CH3, then it is all the same, you write OH towards right or towards left, because this compound will not show any optical activity. So the main condition is that the carbon center should be chiral, and if it undergoes reaction with the nucleophile, so the 2 product is possible, structurally more or less same, but optical activity of these 2 compound in the solution is different, hence it will show optical. You are asked order of nucleophilic substitution reaction. You are asked to arrange in increasing or decreasing order of nucleophilic substitution. Now, nucleophilic substitution means a nucleophile, say OH, sodium hydroxide, OH will replace this emerald, so that bond should be broken. So what are the factors which facilitates the bonding of this bond will give you the answer. Means here in each case it will make resonance with the benzene ring, and this carbon and chlorine bond becomes partially double bond. Am I right? So it is difficult to break this bond if you want to make nucleophilic substitution reaction. Now point is that, are there any substituent attached to the benzene ring which facilitate the breaking of this bond. Yes, because nitro group is deactivating groups. It withdraws electron, it deactivates the benzene ring. So electron will be withdrawn towards nitrogen. So if it deactivates the benzene ring, so the double bond character will be weakened. So it will very easily be broken at carbon and chlorine. So in this, so here there is nothing deactivating group is present. It is least. This is least. Am I right? Now computation is deep. This is in ortho position and this is in para position. So deactivating nature of group in ortho position is more than meta position. Hence, it has more highest nucleophilic substitution reactivity. So your B is the highest, second is C, and least is A. This is the order. The fact is on deactivating group. More the deactivating group, more is the nucleophilic substitution. But if the deactivating group is number is same, then position matters. If it is meta, it is ortho. Ortho is more effective than meta. So deactivation done by this one is more. That is bond between C double bond will be much more weaker than this. Hence it is the highest, it is the second, it is the least. Order of nucleophilic substitution. Again you are to break here. So there must be some groups attached with the benzene ring which may either deactivate the benzene ring or may activate the benzene ring. If it facilitates the benzene ring through pumping electron, so this double bond character will be more stronger. Earlier case was nitro was deactivating group. It deactivates electrons withdraws and double bond becomes weaker. Now here methyl group is electron pumping group. So electron pumping group, the pumps electron here through the resonance, the double bond character will become stiffer and stronger. It will not break. It is not deactivating. It is activating. It is pumping electron. It is helping in the resonance process. But out of this, no such facilitating group is there that pumps electron. Hence, it is the highest. But the fight is in between these two. Now, which one will have more effect of activating effect? Ortho position has more activating effect. More is the activating effect is more stronger the bond is. Am I right? So it is less effectively acting upon this one. It is meta position. So highly reactive is A, second reactive is C, and third reactive is B. Your order is this. So a lots of questions are left to be answered. Hope I will explain this question in my next class in a slowly manner. And please don't forget to watch the video physics in hand. I have done it. I have done a few more classes. Please go through this one and hopes you have understood the class with utmost interest. Thanks a lot for watching the class. Please don't forget to subscribe the class.